Hello and welcome. What I'd like to show in this video is a demonstration of the app restarting capability of Pivotal Cloud Foundry paths, or the Elastic Runtime. We'll start out by deploying an application. Do that with the CF push, allocate minimal memory, it's a very small app, and give the app a name. What we saw scrolling on the screen, slightly sped up, was the staging process whereby that application is prepared for running in the paths. Let's come over to a browser and see that application running. We'll grab the application URL and paste it in the browser. Very simple Hello World application. We have a single instance of this application currently running. Let's see how easy that is to scale to 2 instances. From the command line, we can simply do a CF scale. Say we want 2 instances and give it the name of the application. And just that quickly, we have 2 instances of the application running. We can see that by doing a CF apps command. And sure enough, we have hello paths, 2 instances of the 2 desired instances running. Once we've deployed 2 instances of the app, you might think, well, how am I as a developer or as an operator of this application going to take a look at the logs across my application instances? Cloud Foundry includes a logregator component that does that aggregation for you. In this window, we'll simply type CF logs and the name of the application. We're now tailing those aggregated logs. Let's come back over to the browser and refresh the page a few times. Notice the port number, 867 to start. When we refresh, we see a different port number, 181, and another refresh takes us back to 867. So we've hit 2 different instances of the application running on 2 different ports, and in fact running on 2 completely different machines. Let's come back over to the logs and take a look that we can see the log tailing here has shown application logs for both instances of the application, as well as some router logs. Now, let's come back over to the application and let's take the scenario where I have a part of my application that has a very bad bug in it. So it in fact is going to crash the application. We've got just such a broken part of the application here. And when we access that part, we break the app. Now if we come back over to the command prompt, we'll see in just a moment, there in fact is the stack trace for that crashed instance. If I come back over and I refresh the non-broken part of my application, you can still see that we're still serving traffic on port number 867. If we come back over here and take a look at the running instances of my application, oh, we were too slow. The second instance, the recovered instance, has already started. To show you that that in fact happened, let's come back over to the app and we'll refresh a few more times. Now we've got, instead of port number 181, which was the original second port, we are seeing things on port 999. And of course, still running at 867. So that gives you a demonstration of how that application instance, which crashed, was restarted on as a new instance running at a new port. What I'd like to do is show you a very quick animation of how that works. We'll come over here into this slide. Here's a number of components in the Cloud Foundry runtime, the paths, the Elastic Runtime. We have the router is important in this dialog. The cloud controller is the brains of the operation. That's where the API endpoint is, and a lot of control functions as well. The DEAs are where the application instances are running. We'll talk about the health monitor in just a moment. So you can see in this picture that there's 2 instances of the application running on 2 different DEAs. Those are the droplet execution agents. When something goes wrong with one of those, this is the scenario that we just saw, that application instance has died. How does the system recover? Well, the first thing to note is that each one of the DEAs is constantly sending out messages, basically broadcasting the state of themselves. They don't have to know about the state of the other DEAs, they just know and broadcast the state of themselves. I'm running one instance of app A, 2 instances of app B, and so on. That's all being broadcast to a messaging fabric. One of the consumers of those messages is the health monitor. The health monitor has the responsibility to gather all of those messages from across the different DEAs and build up a model of what the actual state of the system is. The cloud controller knows the desired state of the system because all requests for provisioning of instances goes through the cloud controller, and it's stored in the cloud controller database. So the desired state is fetched from the cloud controller. Then the health monitor does a diff between the desired state and the actual state, and in this case finds a discrepancy. It's missing one of the instances of that application. It advises the cloud controller of that. The cloud controller then dispatches a message asking for a new app instance to be started. In this case, the DEA on the far right-hand side will pick up that message, deploy the application, and then importantly, it sends out another message that a new app instance is running, which is picked up by the router, and the router immediately updates its routing tables, which is what allows us to very quickly go back to our application, hit a refresh, and get routed to a different application instance running on a different DEA at a different port. That's a brief overview of the application restarting capability of the Pivotal Cloud Foundry PaaS. Thanks for listening.